Okay, so what we're going to do is we're going to talk about symmetry with respect to an axis, x-axis or a y-axis. And so we're going to start with the idea, the definition here. So it says the graph. Okay, so it says the graph of an equation is symmetric with respect, w/r, with respect to the y-axis. Okay. If the replacement of x with negative x results in an equivalent equation, which means you get the same equation. So if you replace x with the negative of x, or the opposite of x, and you simplify the expression and you end up with the same equation when you're done, then we know that it's symmetric with respect to the y-axis. Now, if the graph of it, so we would say that the graph of an equation is symmetric with respect to the x-axis if the replacement of y with the opposite of y, or negative y, results in giving us the equivalent equation, or the same equation. Okay? If that happens, then again, so if we take y and we replace y with negative y and we simplify everything, and then we end up with the same equation, then we would say that the graph is symmetric with respect to the x-axis. And so I've got some examples here, and so let's see which ones are symmetric with respect to which axes. Okay? Now, it's possible it might be symmetric with respect to both axes, but we'll have to test each one, right? So if I test this one, let's replace this with the opposite of x. Now, be careful here because this is squared. So if we're going to take the opposite of x, we got to replace inside the square. So we're going to say y equals the opposite of x, quantity squared, plus 4, right? Well, if I simplify this, what do I get? I get, well, negative x times negative x plus 4. Well, this would be like negative times negative is positive, so I'm going to get a positive x squared here. So I'm going to get x squared plus 4. And of course, these are the same. And therefore, what? This has a graph that's symmetric with respect to the y-axis. Okay? So let's see if it's symmetric with respect to the x-axis. Okay, so let's erase this, and now let's do the same thing, but this time I'm going to replace y with negative y. So let's put in negative y equals x squared plus 4. And so now if I solve this and multiply everything by negative 1, I get y equals negative x squared minus 4. Well, it's obvious that these two equations are not the same. And so therefore, the graph of this equation, okay, the graph of this function is symmetric with respect to the y-axis, but not symmetric with respect to the x-axis. Okay. So now what about this one here? Okay, so let's plug in negative x. See what we get. So if we plug in negative x, so negative x equals y squared minus 3. Well, it's obvious we're not going to get the same thing, because if I multiply both sides by negative 1 again, I'm going to get x equals negative y squared plus 3, which definitely does not give us the same result. And there's really nothing I can do to make it the same. Okay? So these are not the same. So the graph of this function, or this relationship, the graph of this equation is not symmetric with respect to the y-axis. So now let's replace y with negative y and see what we get. So again, be careful of the square, so we're going to have to put it inside the square. Okay. Now, very similar, just like what happened over here. Well, negative y times negative y is just going to give me a positive y squared. So I'm going to get x equals y squared minus 3, and lo and behold, they're the same. So the graph of this equation is symmetric with respect to the y-axis, or excuse me, the x-axis, but it's not symmetric with respect to the y-axis. Okay. Now, in C, now if you recognize this from our study of 2.2, our study of circles, then you would realize that this is the equation of a circle that's centered at the origin. And so this, automatically, we can see that this is going to be symmetric with respect to the x-axis and the y-axis. Okay? So, but again, if you want to prove it to yourself, replace x with the opposite of x, or negative x. So we're going to have negative x here. Okay? Plus y squared equals 16. And of course, negative x times negative x gives you a positive x squared. So we get x squared plus y squared equals 16. And then of course, you could do the same thing with the y's, right? So if you start over and you just plug in negative y, well, you're going to get the same thing. Okay, again, you got to be careful. You got to have these parentheses because it's inside the square. And so we get x squared plus y squared equals 16 because negative y times negative y is a positive y squared. And so you get the same thing. So we find that it is symmetric with respect to the x-axis and the y-axis. Okay? Now, what about this one? Let's plug in, well, here's the thing. If we plug in negative x here, it's going to change this to a negative 2x. And there's nothing we can do to fix that, to change that. So there's going to be no way to get this to be the same. And also, if we replace y with negative y, we're not going to be able to simplify this so that it looks, that we get the same equation back. And so in this case, it's not going to be symmetric with respect to either of the axes. Because again, if you just, again, let's just do it. So 2 times negative x, right? So I'm putting in parentheses, plus y equals 4. Well, now I'm going to pull this out, the negative 1 here, so this becomes a negative 2x plus y equals 4. And again, so I do not get the same equation. Okay, so it's not the same. Okay, and likewise, if I do the same thing with the y's, I replace y with opposite of y, I'm going to have 2x minus y equals 4, and I can't do anything with that. Okay, because if I multiply this by a negative 1, this will become positive, this will become a plus, but then I'm going to get a negative here, a negative here. So there's no way to make it come back to the same equation that we started with. So that is going to be symmetric with respect to neither of the axes. And that's all I have. That's it. So again, make sure you ask questions if you have any, and or if you're working on the homework and stuff, just email me and let me know. Other than that, have a great day.